Namaste. This is Professor Pushpavati SM from the Department of Mechanical Engineering, Government Engineering College, Kyarpet, Mandya. And I'll be talking something about the Design of Machine Elements 1 prescribed by VTU for the 5th semester of Engineering. Subject code is 18ME52. See, in the previous session, I was talking about the permanent joints, that is riveted joints, and I was telling I was explaining about some differences between the welding and riveted joints. Anyways, today I'll be continuing with the riveted joints, and the content goes like this: introduction to butt joints. Today, in the previous session, we finished lap joints. Once again, I'll brief lap joints again, because it's a connectivity between lap and butt. No, so types of butt joints, different terms or terminologies used in butt, then proportions of dimensions with respect to diameter and thickness and all. I'll tell about this. What is this? Caulking, L goes into silent, and the fillering. Difference between them is going to be the topics of today's session. Okay, so let me take up some recap of the previous session regarding lap joints. So we discussed lap joint. Lap joints means plate 1 and plate 2 will be placed one above the other. Then the rivet is inserted, and that forms the joint one above the other. Even especially those type of lap joints are subjected to axial loads. I mean to say, if I pull left bottom plate towards the left hand side, the top plate towards the right hand side, means it along its axis, it's an axial force applied. So in that cases, the rivet heads are going to fail. If it's really axially loaded, the rivet heads are going to fail, and the joint is going to fail in case of lap joints. So to improvise the joints, and I mean to say, whenever there are heavy loads applied, so lap joints will not be able to withstand such type of stresses or loads. That time we need to shift for some other joint called as the butt joint. So today we'll speak about butt joints. Okay, butt joint. In the previous session, I told you butting is two plates, one beside the other. So to give a connectivity between these two plates, we are going to use cover plates, or also called as strap plates, I said yesterday, and even we are going to use butt plates also. Butt plate means just to give the support. Butt plate or cover plates, we can say. Butt plates or cover plates, and one more name is like straps also, strap plates also, we can say. So these different plates are going to give connectivity between the butts, and even the stud length, the shank length of the whole stud will be whole rivet will be inserted to the holes of this plate number 1, plate number 2, the cover plates, the strap plates, and the butt plates and all. So finally insertion is done. So we're going to get the strong joints. This type of butt joints are able to carry a high level of load. Means to say, the heavy loads, they are going to carry heavy loads. Okay, so in this type of joint, plates are brought each together without forming any overlap. Here there is no overlap between the plates, because plates are one beside the other. This type of joints are formed between each plates and two cover plates. We are going to use either one cover plate or two cover plate, or one or two butt plates, like that. So additional plates are going to be added in this case of butt joints. Depends upon the number of plates or number of straps used. So the names are going to vary. The arrangement of rivets may vary if the number of arrangement of rivets are going to vary, then we say it's a single butt joint, double butt joint, triple, chain, zigzag type. So there are the different types of butt joints based on the different types of arrangement of the rivets. So especially butt joints are more stronger than the rivet joints. Here also shear force is going to occur. Shear force is going to happen along the plates. So the shear forces can be withstood by the butt plates or the strap plates or the cover plates. We can avoid this type of shear by giving more and more number of cover plates. In this type of case, of course, shear force acting of shear force will be there here, and along the axial loads or the shear force will be acting on these plates, can be avoided by using more number of butt plates or the cover plates, we can say. Okay, next slide. So I said, like, there are different types. Here we are focusing on single, double, chain, zigzag, and different types based on the arrangement of rivets. So here is the sketch showing you the single strap butt joint. Single strap means single cover plate. Single cover plate in the top, you can see the single cover plate, and the single riveted means, so there is a single rivet. single riveted, single strap butt joint, and it's a front view, the front view, the top view, and the side views and all given here. This is one type of riveted joint. Single riveted double strap. You can see single riveted single strap, single riveted single strap, single riveted double strap. See, there is a strap is only one. The cover plate is only one here. You can see this is single riveted double strap. Strap number 1 below and strap number 2 on the above side. 2 straps we are going to use. Both are single riveted, but 2 straps and single straps have been changed. You can see the front and top is on the different side views. These are the different sketches available in machine drawing. Also, you might have studied in the previous semesters. But these are the different sketches available. Different types of riveting available. Next is double riveted double strap. Double rivet, set of rivets. See, there is a set of rivets and the double riveted. Double strap, up and down. So both the sides we have cover plates are the straps. So this is one of the joint. So based on the type of applications, they are going to use different type of rivets. Again, this is a zigzag type. You can see the zigzag here. In the top you can see the zigzag, but in the front view it's look like this. Double strap and double riveted type of zigzag joint, and especially compared to lap joint, bus joints are going to be very stronger and they are going to withstand the heavy loads. That is one of the positive point on this. Next, moving on to the next slide. So there are so many important terms used in the riveted joints. I mean to say, you can say that these are the different terminologies used in riveted joints. So basically, see, 4 numbers have been given: the pitch, the transverse pitch, diagonal pitch, margin, and marginal pitch. For this, I have one more sketch here. So you can see this sketch. Terms used in riveted joints. Different terms. This is the P, PD, PT, and M. I mean, so margin, marginal pitch. So you can correlate the sketch with respect to this, different terms given. Pitch, transverse pitch. Pitch is the distance from center of one rivet to the center of the next rivet measured parallel to the seam as shown in the figure. It is usually denoted by P. You can see this is the pitch. Difference between these two is called as pitch. Distance between center to center of the rivet. Next comes the transverse pitch. Transverse pitch, that is, you can see the transverse pitch. Transverse pitch is given by PT. It is a perpendicular distance between the center of line to the successive row to row distance. This is one row and this is another row. This is the successive distance between 2 rows, gives you PT. This is a P between 2 studs or 2 rivets, and this is the distance between 2 rows, that is PT. Next comes the PD, the diagonal pitch. It is the distance between the centers of the rivets in adjacent rows of zigzag riveted joint as shown in the figure. It is usually denoted by P. It's like a zigzag way. You can see here, zigzag way. It is in the Z shape. The distance between this rivet to this rivet, PD like this, or in this way also, this way also. This we mean to say it in Z axis, we can say. I mean the Z shape, we can say as PD. Next is the margin or marginal pitch, M. It is the distance between the center of rivet hole to the nearest edge of the plate as shown in the figure, M. This is M. This is M. So margin to the nearest rivet. The distance between margin to the nearest rivet, distance between the center of the rivet hole to the nearest edge or the margin, usually denoted by M. These are the different terms we are going to use in rivets. Pitch, P, transverse pitch, PT, diagonal pitch, PD, margin or marginal pitch, M. Okay, this is the diagram for that. Next comes the proportions of dimensions. So we should have some proportions of dimensions because T is the thickness of the plate, D is the dia of the rivet, M is going to the margin. Just now I was speaking about PT. You guys know what is this PT is. PT is the transverse pitch. You know PD is a diagonal pitch. So they all have some proportions. 1:2, 2:3, 3. If it is 1, that will be 6. If dia is equal to 1, thickness will be 6. It is something like, there is a relation, okay. So those are the relations I have listed out here. Thickness of the plate is given by T. If the then the diameter is given by D is equal to, diameter is given by D is equal to 6 root T. If I have some thickness T, if I have some thickness T will be substituted over here, then the 6 into root of that value of T gives you the diameter. That is the relation between thickness and the diameter. Next, distance of the center of the rivet space 1.5 of D, margin M is equal to D. Margin will be given as same as diameter. So distance of the center of the edge plate is 1.5 D. longitudinal pitch P is equal to 3D, transverse pitch PT is equal to 0.8 of T, then PT is equal to 0.68 of P for the zigzag plate. Zigzag joints also we discussed, Z shape. For all these things PT is equal to V. Transverse pitch is this, if it has a zigzag, chain riveting and zigzag riveting, two types of riveting I told you, no? Yeah, in this sketch, this is a zigzag type of sketch, the zigzag type of riveting. One more is like, chain. Yeah, this is chain. This is chain and this is zigzag type. For these things, so they have some different proportions. Proportions like this, 0.8 of P, 0.6 of P. Okay, so the thickness of the strap, a single cover plate T1 is equal to 1.2. While solving the problems, you can understand the proportions also. Just for reference, I have given you the proportions as well as the different terms used. These are different terms. These are the proportions in case of joints. Next, the major important part is this caulking and fillering. I told you in the very first session that especially this type of riveted joints are used in civil as well as in mechanical applications. So coming back to mechanical applications, I told regarding some boilers, pressure vessels and etc. So they are highly pressurized type of equipments or we are using in mechanical engineering. They were having high temperature and high pressure. So and we need to make the boilers as leak proof. That is a challenge. We need to make our rivets, the boilers as leak proof. Okay, in order to make this, caulking is one of the operation to make the joints leak proof or fluid tight or leak proof pressure vessels. So and you can see there steam boilers and hydraulic tanks I have given here, steam boilers and hydraulic tanks here. So this process is called as caulking. So how this process is going to exactly happen, how we are going to avoid the leakage here. See here, there is a sketch representing here. This is one of the butting done. To say the rivet joint has been done. The lap joint. So this is one of the lap joint. Plate number 1, plate number 2. This is the rivet head and riveting is done. Okay. So caulked rivet they have given you. This is riveting tool. This one, no? This is called as riveting tool. Okay. This riveting tool is very small. It is called as a round tool. It is actually called as a round tool. This one here at the end. So this will be hammered here. This tool will be hammered. This tool will be hammered. You can see it's about 5 mm thick and 38 mm breadth. The tool is about, it's a narrow tool. This process is a narrow blunt tool that you're going to use. It's about 5 mm thick and 38 mm in the breadth. I'm speaking about the tool, and this 80-degree angle. So here this will be beveled. The edges of the plates will be beveled. They are going to bevel the edges, and see this gap they are going to fill using this this tool, round tool of this dimensions and all. They are going to hammer here. They are going to hammer such that, so they are going to avoid the small gaps here. Small little minute gaps can be avoided by using this type of tool. This is called as caulking application. So where this particular operation is done on the rivets just to make the riveted joints leak proof. There should not be any leak in the boilers and the hydraulic tanks. To get this job done, we are going with caulking. This is a tool used. This is the method of hammering. It is at 80-degree tool at 80-degree angle. So this beveling is done, and finally the gap between the plates will be avoided. The edges of the tool is ground. That's an angle 80 degrees. So same thing is given here. Let it be. Next, so applications of this caulking procedure. This is one of the oldest method here. So use it for wooden boards, shapes, watertight or by driving fibrous material into the wedge-shaped seam between boards. Where and all it is applied. Wooden boards and ships, you can say. So used in buildings also, used in industries also, used in tunneling also. There are so many applications. The applications have been listed. Even the same material is available in the content also. You can see it. Next, one more operation, same with the same intention. We have one more methodology called as fillering. So a more satisfactory way of making the joints strong is known as fillering. So leak proof is caulking, and to make the joints are more stronger is called as fullering application. So which has largely superseded by caulking. So this process is called as fullering. Here we have a tool here. You can see the previous case the tool was very small, like 5 millimeter in length and 35 millimeter along the breadth, something they were telling you, but the same degree, 80 to 85 degrees the beveling here. You can see this is the tool. This is called as fullering tool. Fullering tool is very much equal to the thickness of the plate. Same thickness of the plate. The tool thickness is equal to thickness of the plate. Again it is hammered here. Same thickness is used. So here when we blow this hammer, so this will give the clean finish between between these two metal number 1, metal number 2. So there should not be any gap between. So between these two, it will avoid all the gaps, and it will make, so give you more clear finish. So there is no risk of damaging the plate and all here. So this is done again to make the joint more and more stronger. This is the fullering application. Of course, there are some differences between these two operations, caulking and fullering. See, this is used to obtain leak proof joints. It's carried out by using a narrow blunt tool. Again, in both the cases, the tool is again different. Okay, thickness is 5. Surface finish obtained in compared to fullering is less in case of caulking. So more risk of damaging the plates. Here there is no risk. Fullering in the explaining only, I told you there is no risk of damaging the plates. It's a clean finished operation. I know thickness of the tool is very much equal to the thickness of the plates. Special different tool is used. So it is obtained to get the leak proof joints compared to even much more leak proof joints as well as stronger joints. One more advantage is stronger joints can be obtained in case of fullering. So this is the difference between caulking and fullering. So thus in today's session we discussed about the lap joint, why we are shifting into butt joint, how they are strong enough compared to the previous one, because they are going to withstand heavy loads, and different types of butt joints. There are some 3 to 4 different terms used in it, proportions of the dimensions and the caulking fullering operations. So why these two operations have been done and what are the differences between these two. And this is about the today's session. So next in the sessions we will be continuing about a few more topics on this riveted joints. Thank you.